Welcome back, everybody, to Two Deans and No Waiting. For the first time ever in the studio, we have a debate. That's right, between the flat Earth theory people versus whatever that is, the round Earth theory. Right? That's what we were.
Pseudoscience.
That's what we were taught when we were kids. The Earth is round, right? But if you were around 500 years ago, the conventional way of thinking would be that the Earth is flat. And I want to thank my two guests here today. From the other side of the ice wall, we have Rick,
That's me.
who is a flat Earth
Theorist.
who believes that the Earth is flat. And for the first time in our studio, we have Brandon, who thinks the Earth is round, the conventional way of thinking, right? So this is our first ever debate on Two Deans and a Waiting. Besides me and Dean always fighting, and I'm always right. He's not here today. He's back at the Betty Ford Clinic. I wish him well. But Brandon, I want to thank you for coming on the show. It's the first time you've been here.
Thank you for having me.
And Rick's been a guest many times, and he's from the ice wall. So this guy knows a lot about the flat Earth theory. But my first question I want to ask Rick is, what made you, and it's a personal question, what made you decide that, hey, the Earth is flat? When was your burning bush experience?
At a very young age, reading the Bible with the firmament above and the waters below, eyes at bottom, things like that got me going, got me thinking, and then just growing up, I never believed what they told us.
So you never once thought that the Earth was round.
I
So you were always convinced that, hey man, this is fucking bullshit.
I didn't believe in the moon landing. I never
different.
grasped the concept of how they were trying to present us rotating through space as fast as it is, and the theory of gravity and all that. I could never grasp it. I never understood why.
So you always believed the Earth was flat.
Always,
Okay.
Always.
All right, and Brandon, what makes you think that the Earth is round and not flat?
So from a pretty young age, I've always had kind of a interest in physics, and as I've gotten older, I've gone more into astronomy. I've studied different theologies throughout my life, and I've never found any convincing evidence that it's not flat. So I feel like in order to convince me of something otherwise, I would need some pretty significant proof.
So you're 100% sure that the Earth is round?
I never use the term 100% sure. I'm probably 99.9999999% sure that the Earth is round. There's always some room for wiggle.
And also too on the flat Earth theory. The theory is that it is a circular, flat planed, concaved.
So it's not flat like a pancake?
No. The theory of it is it's a flat, non-rotational plane. That's the theory on it.
It would be more oval.
Yeah, with a concaved edge, and the concaved edge, of course, is the ice wall that goes around it.
And I know
with the firmament above.
You're from the other side of the ice wall.
So
I
went through and I seen.
Yeah,
so are you from the flat Earth segment that believes that it extends beyond the ice wall? That there's further
with the lands beyond. Yeah.
So you don't believe it's more so of a disk, but it extends infinitely in each and every direction?
Yeah, I think it's a disc, but then I also, and this comes from the Admiral Byrd, Operation High Jump and things like that, and also texts and beliefs and things like that, that there's lands beyond, and so you get outside the circle, and then supposedly there's lands beyond, and them are the lands of the gods of like Nibiru and Atlantis and the lands of the giants and things of that matter.
You're going back.
Yeah. Old ancient texts
with
of
the
things.
Anunnaki.
Yes, and they say there's even lands of the Draconians and the Drago, they call them. The reptilians.
Okay,
like
but
that.
Okay, now let me ask you a question here, and I know this question's probably been brought up a million times. My only proof that the Earth is round is two things. I've been to the Empire State Building, huge, and I can see the curvature of the Earth. And I've also boarded a plane to go from here to Greece, and I could see the curvature of the Earth. What's all that about?
Well, your eye, they say, well, of course your eye can see as far as the plane goes.
So you're saying that's like a optical illusion?
I wouldn't say that. But there's different things to it. I mean, the
Because some flat
the
Earth,
fisheye lens, and
Yeah,
then they
that's what
say
some of them believe.
what really gets. I understand what you're saying about the thing. What
Right.
really gets me, like, you go south and you go to what is it? It's in Georgia, that mountain point where you can see the 7 different states or whatever, and you look above that and you look out, and it's just, you could see tiers of things. It's not like, what is it? Every, what is it, 1,000
Mile.
feet or whatever mile, it
Mile
drops
to 8
6
inches.
foot or 8 inches or something like that. I mean, so to do the math on that, you
So-
wouldn't see them things. It's
do you want to rebuttal what he's saying? Go ahead. And,
I don't know the math like you.
I'm
Yeah,
just-
so whenever you're trying to take measurements from Earth, it's very difficult. One, you have like different terrains. So the idea is essentially that you line up a laser that's very, very level, and then you have it really advanced instruments to try and level out that laser. And whenever people do this on an independent level and try and level out that laser and then measure how high off it is the ground after a very long distance, you get different measurements because of different land terrains. Are you measuring on a hill? If you're measuring over water, are you taking into account the tide, the water? So the tide, a lot of people think of the tide is like the shore coming in and out, and that's what most people think of the tide. What the tide actually is whenever you have a body that poses gravity above a body of water, there creates a lump over the body of water to where the center of the body of water rises, and then it draws the tide out. And then whenever that lump recedes because of that body no longer being over the ocean or whatever body of water you're measuring over, it causes it to go back down. So there's several different things, and these studies would need to be peer reviewed heavily in order to get an accurate result and to make sure that the math was done correctly. And people have had varying results whenever taking these types of measurements.
So how did they do it 260 years ago with stone and string and stuff like that? And a little little scope, little eye scope.
I believe that many of them have had the wrong conclusion over the 200 years ago, that whenever they've taken it, you take a model in which you believe that the sun to be 6,000 miles over the earth.
No, I'm talking about land surveyors. When they did landmarks and surveyed land all them years ago.
So 200 years ago, a lot of people didn't know. I mean, like not 200 years ago.
How did Lewis and Clark get across? Wasn't that their expedition?
I mean,
Wasn't
the
that
United
what-
States of America is a somewhat recent discovery for a lot of people. A lot of people, if you go over 200 years ago, 300 years ago, didn't know a lot about the terrain of the Earth. So you're saying, how did they conduct these experiments? Well,
How,
they
whoa, how did they know about the terrain of the Earth when you got maps that depict what the Earth was 600, 700, 800 years ago?
you believe those maps to be flat, and I believe that they aren't.
I didn't
So-
say nothing about them being flat. I'm asking you that it shows terrains. I mean, it shows continents
Yeah,
that are around 600 years ago. So
they believe the Earth to be
yeah.
flat. Various different.
No, but like, how did they do the measurements and who did the things and the graphs and how did they determine all that and who went across and
I'm not sure the exact mechanisms of which they tried to measure.
Now, how does that prove that the Earth is flat or round? For people like
what I'm saying, how would they know to do the math if the Earth was supposedly a curvature and the curvature thing?
So how did they
didn't
know?
come- yeah, that's what I'm asking.
Okay, yeah,
That's what
well,
I'm
how-
asking.
yeah,
It's-
that's a good
these are
question. I think
things-
it's a
These are
fair
things that I think of
Right.
when people try to present that model to me.
So
I
I
psychoanalyze it.
if the people who you're I don't know who you're referring to, but if the people who you're
George
referring
Jefferson, all them.
if
all
the
them
people
guys.
who are you're referring to conducted that study and then got a result in which the Earth is round, I believe they did it falsely.
No, I'm talking like just in general, like here in America when they were surveying the land to go, scout things and make a colony and stuff like that.
Okay.
Them guys. When
But you're talking 200-300 years ago.
Yeah. How
Okay.
did they know to do the math?
Well, 500 years ago, like I said, the conventional way of thinking was your way.
Yeah, but
It was wait a minute, you believe the Earth is round? You're going to fall off the face of the Earth kind of bullcrap. So I mean, I kind of understand what he's saying,
but also in Hindu texts dating back 1,000 years, it talks and shows you the firmament.
So the Faraman is what? I'm kind of.
I'm not exactly for sure. What they say
What
it's
is the
like
Faraman?
they say it's like an ice barrier, like a big huge ice barrier above us,
Now let me ask you a question. Oh, hold on. Just because
like
there's
an ice cube.
Okay, so the ice barrier, how's that? Like, if there's an ice barrier, why does that say that the Earth is flat?
That I can't answer.
Okay, because an ice barrier could be there and the Earth could still be round.
And
Because I know with the flat Earth people believe in the ice wall, but couldn't there be an ice wall? And even if the Earth is round, there's just and there are ice walls in
in
Antarctica.
in Antarctica,
Sure.
and up north, and stuff like that,
Okay.
North Pole.
So, because I'm
But you want to elaborate on what
Okay.
on what he said?
I'm
Go
gonna
right
show
ahead.
the live stream something real quick. So essentially, the difference between the two models is if you were to take the traditional, what we were taught in school, flat or round Earth model, and then you were to go down to the southern pole, which is Antarctica. Flat Earth says that pole doesn't exist. Rather, it's a ring that wraps around the rest of the continents.
Right.
So you get the same sort of map conclusion on both models, but I believe that there's areas in which flat Earth falls short. And these aren't areas of, measurements and things that can be easily, miscalculated, things that require exact, precise calculations. These are fundamental principles that we observe in the universe. For instance,
Okay, what are you going to show on this globe here?
Okay.
Made in China. Okay.
yeah, so on this globe, this is what flat earthers believe is the center of the universe, which is the center of the.
Okay, if you could show the. No,
Yeah.
Go ahead. What is that?
This is the Arctic Ocean.
Okay, I know. I know what it is,
North
but you're
Pole.
described. Yeah.
Yeah,
I know the
so
North Pole.
essentially
I know
on a
that much,
globe
geez.
model, the Earth spins from west to east, and then you have the northern hemisphere, which is everything that's north of this line, this equator
The
line.
equator, right.
Yeah, and then on the south hemisphere, Globus, which would include myself, and most of what you'll be taught in school will be related to this, say that this is Antarctica.
That's Antarctica, right?
Yeah, this is the southernmost points on the planet. So this is where a compass would point south.
Is there an ice wall?
If you're referring to, is it wrapped around the rest of the world? No.
So they
it's
think.
not.
Okay. So the flat Earthers, because I want to get this straight.
There
too.
are plates.
You guys believe that the ice wall is wrapped around the Earth,
Yep. Its circumference is it.
so it's a circle. The ice wall is a circle, but the Earth isn't.
No, there's a circle.
It's a circular.
So-
Yeah, it's circular.
That's what I was
but
showing.
It's a flat concave surface.
So the Earth would be like this.
Just
the
take
half
the
of it.
bottom out and flatten
Yeah,
it out,
okay,
and,
right,
and see
right.
that ring right here?
Right,
Would
exactly.
be like the Arctic
Okay,
Circle.
okay,
Let me
gotcha.
let me show you what I just
Antarctic
showed
Circle.
them on the screen because you didn't
All
see
right.
it. Essentially, this is the round Earth model.
Yeah.
And flatten it like a pancake.
And then if you take Antarctica and open it up, then it
There you go.
creates
Okay.
the flat Earth model. So
So
Antarctica,
you think that's a bunch of freaking bullshit? That's
yeah,
what you think.
Essentially. I mean, I don't mean to insult people. Who have
I get it. You
contrary-
on this show, buddy, we insult everybody. I don't give a shit who it is.
Holds
Insult. You insult whoever. It don't matter. We're not in school anymore. But okay, all right. That makes sense. That because I really don't have a dog in this fight. My forte is really geopolitical politics, foreign politics, domestic, and I like to beat the shit out of Dean when he's here. So he's not here, and I'm pissed because I got nobody to beat the shit out of. But I'm just kind of like trying to get into this, and like I said, that's interesting. And what you say is interesting. What you say is very interesting. Like I said, I'm torn in the middle because I'm more prone to thinking I don't believe anything I was taught was freaking real. But I get what you're saying. Where'd he go? He's a magician today. Where the hell you go?
So
Okay, you're gonna show us something else. He's bringing something out. Don't bring any live animals out of it like Johnny Carson.
So essentially, what flat earthers believe is that since the Earth is basically like a disk, and imagine this is the firmament or the dome
Yeah.
that's above the disk.
Okay.
They believe that all of the stars are rotating counterclockwise around a star called Polaris.
Right.
Okay, is that true?
Stars
That's true.
Yeah, they believe that the
Okay,
star-
so you believe that there's a star called Polaris?
Yes.
That's real.
So the star called Polaris on the round Earth model is directly, it's in the same position, both models, all it changes
Okay.
is the south pole.
Okay, so flat earthers and the people that believe in the conventional way of thinking both agree that Polaris is
Polaris is
right.
directly over the North Pole.
Now, let me ask you a question. Now, they don't believe in the continental drift. Do you believe in the continental divide? At one time, the continents were all together. Do the flat earthers believe that?
Yeah.
So they do.
Yep, because that falls into Bible text.
Okay, so years ago, millions of years ago, you believe that the continents were all together. So then you do believe in the continental drift.
The
And
only
of course,
thing-
I
the
know.
only disagreement between flat Earth and round Earth is usually the timeline in which that occurs. Round Earth believes that there was something called Pangea, which was like several million years ago. That you see the coast, like if you look underneath.
That's when the continental
oceans,
drift started.
Yeah, if you look
Settling.
underneath the oceans, there's lines where you can see the landmass beginning to spread, but it travels much slower than what most flat Earthers say.
It's like a jigsaw puzzle. You can see that. Look, at one time it was all.
Yeah, and they say the landmass, they say this landmass here of America and that will actually fits perfectly together.
Of course.
But,
Okay,
you
so
know,
so we all agree on
and they
continental
say,
drift.
they say
an
the
agreed
geological
Okay, all right,
structure
all right,
over here.
Because I'm with you guys on
Yep,
that.
the geological
That's-
structure here on the east coast of the United States.
Yeah, sure.
is
It's like a jigsaw
similar.
puzzle,
Is
right.
similar with Ireland and the UK
Right.
and things like that.
Yeah, so
Pangea is a proven
it's
concept.
it's just the timeline. Now, I don't want to drift off, but I got to ask you, the moon. I'm more relative believing the moon is like 4.5 billion years old, and it's created from the Earth. I don't know what you talk about the moon being a plasma. Now, there's different theories of the moon. I know it's not made out of cheese, right? I know we're going to argue
we
that.
went to it.
Okay, all
Well,
right.
that's when we all
that's
agree
all-
it's made out. No, I'm just kidding.
That's a whole different story. I'm with you on that one. I don't believe but that's a whole different subject. I don't believe they went either. But it's propaganda or whatever. But I do kind of believe that, I don't know what the flat Earth people believe, but it was created. They say 4.5 billion years ago, from meteors hitting the Earth,
Yeah.
therefore creating the moon, which took 4.5 billion years or whatever.
Yeah. So essentially, if
explaining
you,
that
if
is
you take
kinda difficult.
if you take like a bunch of marbles, a lot of people have questions on like, why do all the planets orbit the sun?
The moon is round. You can see the moon is round.
Yeah. Well, I mean, some flat earthers think it's also a disk, but
It's a reflective plasma ball.
Explain that.
So do you think that it's spherical, or do you think that it's a disk that's just facing us?
I think it's just a disc facing us, and it's a reflection, a plasma reflection moon. Like a mirror. That's what I think it is. And if you look at the flat Earth model, and then you look at the moon.
So
model,
this is.
If you
I
look
was
at
watching a TikTok live stream. Does this look like it would be a disc potentially, or does this look like it's probably?
Show the
curves?
people. I feel like Vanna White right now.
You want me
Can't
to
see.
run it over there so the people can see?
The people can see the two listeners or the two subscribers,
so if you look
the two people that are probably using the toilet right now.
if you look at the moon and you look at the flat Earth model, the moon's reflects what the flat Earth model is.
Okay.
Do you know what I'm saying? The flat Earth model of
What?
the continents reflects what the moon's facing is.
Now I believe in. I hate calling conspiracies because they're agendas. When you use the word conspiracy, you're already demonizing
and
something.
you know it's a CIA.
Of course, it's a CIA word, of course, like Al Qaeda, right? That was all CIA. And I get it. So there's always an agenda, and I do believe in agendas. Although this one here, and I'm asking him this question: why lie about the Earth being flat
From my understanding,
or being round?
Yeah, from my understanding, they've always believed that it was a circular plane, But from my understanding of why they put the globe model into it, it was the introduction of taking, of putting Satan in front of us and taking God away from us, taking the religious aspect away from it and putting a pseudoscience in front of it. A lie, a deceit.
You can rebuttal anytime you want, but before
That's
you
what
rebuttal,
they say, but
and-
everybody's got, again, who am I? I wasn't back 500 years ago or 400,
Now-
whenever they came up with the
Now, okay,
globe.
so
I don't even know who it was, Galileo? Wasn't it Galileo?
Galileo was the one that discovered.
Didn't he come up with the globe? Who was it?
Isaac Newton. I'm thinking of gravity.
Yeah, gravity was.
Isaac
gravity.
Newton created classical physics.
Yeah.
I forget.
That's-
I think
yeah,
it was
you were
I
talking
think it was
about him.
Galileo. I think it was Galileo.
Now, Rick. Before you slip into the ice wall again, come over this way so the people can see your pretty face, and we can lose more subscribers.
There you go.
But what I wanted to ask, since you believe the Earth is flat, but you also now some flat earthers believe in there's a dome.
Mm-hmm.
What's the dome for?
The dome is.
Is this something God created?
Yeah, that's what
Okay,
they
but
say.
the
heavens above as the heavens
Okay.
below.
Okay, so of course a lot of people believe in intelligent design.
And if you dig
Yeah.
into Operation High Jump, when Admiral Byrd went there in the 40s,
Right.
and
Degrees.
they did
How
that,
can you prove that there's a dome?
they give you the degrees, like 80 longitude or whatever it was, and he talks about it in his
How did he know that there's a dome?
Evidently, they said they touched it.
You can
You know,
touch like an invisible force field.
Yeah, it's like I said, it's like an ice barrier. It's like a huge ice cube.
What's that to protect us from? But then again, meteor crashes.
Well, they
how
say-
do you explain meteor crashes?
Well,
and that's how the moon was created, if you believe
right?
that.
Yeah, but when have we had a meteor? When's the last time we've had a reported meteor crash?
The Siberian.
And how do we go
It was-
through
okay, in
the
1912.
galaxy without being hit by all them meteors?
1912, the Siberian forest, there was a meteor crash. They said if that, and this is what they say, I'm just repeating,
Yeah,
don't
yeah,
shoot the messenger.
yeah,
It's in
yeah.
ancient Greece. Okay, they said that that meteor that crashed into the Siberian wilderness, Siberian forest, that was early 1900s, would have destroyed Manhattan, would have destroyed New York. It totally destroyed like 70% of the forest. So that happened in 1912. Now, if there's a barrier there, why wouldn't that protect us?
I don't know. But who's to say that that did happen, though? And why hasn't it happened in 115 years? How come another meteor hasn't
So
hit us
if-
in 115 years?
I know he don't believe in the dinosaurs either, that they existed, because that's supposedly
Well,
55 million years ago that killed off the dinosaurs.
I don't believe that we had like dinosaurs. I believe we had larger animals, like prehistoric animals.
What's the
word dinosaur didn't come in existence
I
till
don't-
like
So what do you-
70 or 80 years ago, right around when Rockefeller took over.
So why lie
prior
about-
to that? It was dragons and griffins.
Why
and
lie?
things like that?
Why lie about dinosaurs though? I know fossil fuels bullshit.
Right there,
That okay.
Right there.
I knew you were
Right
going to
there.
get to that.
Right
I know
there.
that's bullshit.
right there, and scientists will
Okay.
tell you it's
I,
bullshit.
yeah, there's things that are totally bullshit. Okay, now you want to rebuttal anytime? Go
Yeah,
right ahead.
so essentially, I looked up on people who initially discovered Earth being round, and it says that it's the ancient Greeks. So I'm not sure if
That's
Galileo had it.
that's my people.
Yeah. Oh, good. So anyway, I want to get back to the globe model. What I was saying before is that you have the North and South Pole, but to summarize, I'm not sure how much time we have. Essentially, there's also something called the North and South Celestial Pole. So if you take the dome model, and they believe that the Earth, or they believe that the stars rotate counterclockwise around the centralized
Would it be
star.
the dome would be around like what? Put
Yeah,
the,
so
that would be
Straight
the
on
dome.
top.
Dome would be straight on top. And then the centralized star is known as the North Star. It's also referred to as the star Polaris.
And maybe that's why they can't get to the moon. It's because of the dome.
Dome,
This is
yeah.
what you're saying.
Yeah. So,
Well, they say
Only-
that you can't get through the Van Allen belt. How did we get
Okay,
through the
yeah.
Van Allen belt? How do they know we can't get through the Van
With the
Allen
asteroids,
belt? But we
right?
went
Winter-
through the Van Allen belt to get to the moon. How do you contradict yourself with that?
yeah. So I want to get back to this subject because
Okay.
I really wanted to.
I'm sorry,
I
go
don't know.
ahead, go
I don't know
ahead.
how you said you have to be done by.
We're,
2?
we're good. We're good.
Okay.
We're good.
Okay. So
Yeah, he's got time.
I guess I don't have to speed run it. Essentially, the only thing that fails to explain is all of the rest of the star chart. So if you're looking at the northern hemisphere, flat Earth is correct. We do observe all of the stars spinning counterclockwise around the centralized star Polaris, which is
So they believe that. Everybody believes in that.
yeah,
It
which
goes.
is
It goes east to west.
which is above here. The only issue with that is, okay, so here's an experiment that the audience can conduct at home. You might feel a little silly doing it, but if you stand up and you put your left arm and you start to turn from right to left, you can notice three different things. One, if you look up at the ceiling, you see the ceiling spinning around a centralized point counterclockwise. Second thing you'll notice is that the room in front of you is spinning from left to right. If you're spinning from right to left, the room in front of you is spinning from left to right. Third thing, which this is the important thing to notice, is whenever you look down, you will see the floor beneath your feet is spinning clockwise. So the ceiling is spinning counterclockwise, but the floor, which is 180 degrees away from the ceiling above you, is spinning clockwise. Now, where flat Earth model fails is one, a simple kind of Achilles heel of flat Earth model is our star chart, which doesn't have the same blind spot that the Earth has, because people can't really afford to go to Antarctica to verify that's not a centralized point.
He was
Our
just there
star
20
chart
minutes ago.
is round in all directions. There's no blind spots on our star chart, so we can map out the constellations and see 360 degrees in all directions. But what I'm getting to is the southern celestial pole, which is 180 degrees away from Polaris. All of the stars rotate clockwise around the southern celestial pole. So if you were to spin the planet from west to east, you see the stars spin from east to west. You see Polaris, all of the stars are spinning counterclockwise around Polaris. But then once you go south of the equator, you begin to see a constellation called octans. And all of the stars are spinning clockwise around octans. That's because it is 180 degrees away from Polaris.
So you're saying that proves that the Earth is round
So
because of that spin.
So there's two different things, but it becomes a major issue in which flat Earth fails to explain. If the star chart is round, and up here is where Polaris is, and we have a flat surface, we should not be able to see below the flat surface to 180 degrees away from Polaris. And it's all that one singular axis. You have Polaris up here, and you have octans down here. You should not be able to see, if all of the stars are rotating counterclockwise, you should not be able to see a portion of the sky that is rotating clockwise. And you should not be able
So
to see
if it's flat, you can't see that.
You can't. Also, just like the simplified concept would be the star chart goes in 360 degrees. There's no edge. There's no point where we can say, okay, we can't see past this constellation to see where it comes back around the other side.
Okay.
So if you can see below the plane to see this bottom portion called octans, how is it that flat Earth would possibly be able to explain a method in which we
you're
can
right
see underneath?
So you're right here.
Yeah.
You're right at the bottom.
Yeah, so you can see the southern constellation octans from South Africa. You can see it from Australia.
And you can
half of the planet can see it. Okay. So the northern half of the planet, if you were to look at Polaris, which is the northern star, it's there all day. You can't
so
see
half
it.
of the planet can see it, the other half can't, because the world is not flat.
Yeah,
it's
so
round.
if you live in the United States,
Right.
you can see the northern star
Right.
in the same position all day. Now, it's half of the day you can't see it because the sun's out. But whenever it comes, whenever the stars are out again, it's going to stay in that exact same position all day.
It doesn't
That's the
move,
only
right.
star in the northern hemisphere that doesn't move. All of the other stars spin counterclockwise
Gotcha.
around, or it's because we're spinning. I'm generalizing, saying that the other stars are spinning, but all of the other stars spin counterclockwise around.
So we're
Polaris.
moving through space at what?
Yes.
At 30,000 miles, right?
No. So around the equator.
How fast are we going through space?
It's relative to what's moving. If you're looking at
Well, yeah, I'm just asking the question.
we're orbiting the Milky Way at
60,000 miles. I said 30,000.
67,000.
Okay, 67,000 miles. Well, it is kind of relative because my point is the flat earthers think, well, we would feel it, number one. Number two, how is that?
Earth is orbiting the sun at 67,000
And you
miles
believe
an hour.
that we're
The
not
sun-
moving through space like that. That's why it's relative.
The
because-
sun is hurtling through the Milky Way at 514,000 miles an hour.
Okay.
So Earth is orbiting.
While Polaris stays in one central point,
Yeah. So,
we all just infinitely just fly through space miraculously in one galaxy called the Milky Way. Correct?
absolutely. Yep. Do you
Yeah.
know how big the
Okay.
Milky Way is?
It doesn't matter.
It does matter.
No, it doesn't.
It does.
Because
Let me
how
explain why it
can no,
matters.
hold on a minute. Let me ask. How can all that stay in one centralized place, but just rotate through space infinitely and us not feel it.
So let me ask you a question and you just take a random guess. The closest star to the sun is 4 light years away. That seems like a small number.
How do you know that? Who measured that?
We can measure that through a method in which we measure the red shifting of the stars around us.
With your make-believe science? With your pseudoscience?
I mean, it's all pretty accurate. Okay.
So that's a theory too.
So I'm giving you an explanation to your
but
question.
that's what cracks me up is the pseudoscience that they try to teach you and tell you is illogically impossible.
Why is it impossible?
How the hell did you tell me that it was 4 million light years away or 4 light years away? How did you measure that?
So
what tools?
You're asking multiple questions.
But I'm trying to make a point here.
Wouldn't math? Wouldn't you measure it by math? Right?
Yeah.
What math are you using? Who has a telescope that big to do that?
I mean, he brings up
James
some
Webb.
good
I
points.
mean,
James Webb.
and if you are spinning like this, just continuously,
1,040 miles an hour.
how come we can walk, but we can get on a merry-go-round?
Okay, so
let me
we gotta
finish. But we
answer
can
one
get
question
on
at
a
a time.
merry-go-round and spin us infinitely, and we get off and we're all fucked up. But we're spinning 1,000 miles an hour.
Okay, I'll start with that question
Yeah.
because we got to do one question at a time. You kind of went on, asked a lot of things.
I like it.
These are
Okay,
the things
good.
that make me go.
so you bring up a good point. Earth is spinning 1,040 miles an hour around the equator.
But hold on. But when the Earth is spinning 1,040 miles an hour, up at the top here, it's not spinning as fast, and down below, it's not spinning as
That's
fast.
That's why
But
things
here
weigh
in the
more.
middle, it's just spinning so
Interestingly,
fast.
you can make a prediction, and based off of that, things weigh 0.5% more at the poles than they do at the equator because of this concept. Now, let me explain something about inertia real quick. What you're explaining with the whole merry-go-round thing, that's based on Isaac Newton's first law of motion. It's based on the law of inertia. Essentially, whenever you're let's take an example. Say you're in the car on the highway and you hit the acceleration. What do you feel? You feel pressed back, right? If you hit the brakes, you feel pressed forward. Well, you're going at a constant speed. You can toss a ball in the air as long as the windows are up. You can toss a ball in the air, the ball fall back down in your hand. You feel at rest. You don't feel like you're moving. Everything around you seems like it's moving, but once you reach a constant speed based on inertia, you feel at rest. Now, here's the more the point that would apply to your scenario of us spinning. Whenever you turn off of a highway, you feel thrust in the opposite direction. The law of inertia basically says, Isaac Newton's first law of motion says that items at rest tend to want to stay at rest, and items at motion tend to want to stay at motion, traveling in a straight line. So whenever you turn off of the highway, you feel your body wanting to travel in the direction it was traveling previously. That's what you're explaining right here with inertia. But in order to calculate inertia, you need to know two things. One, you need to know the speed in which you're traveling. Two, you need to know the rate in which you are changing degrees. So,
Okay. All right. Good point. You both great. I love it. So I'm going to ask a question because we talk about the laws of physics and the laws of motion. Now, what about gravity? You say it's a theory too. Gravity holds everything together. But why, when you go into space, there's no gravity? It just shuts off and
weaker.
Yeah.
What's that?
Yeah.
Gets weaker.
Because that's kind of
Here, let me
that's
give
a
an
good
example.
point.
Let me give an example.
Gravity is here on Earth, but all of a sudden in space there's no gravity, so it kind of shuts on and off. Explain that to me.
Here, let me. I mean, if you guys want to talk.
That I know flat earthers always talk about that, right? Okay. Boy, you're just using everything today. I didn't even know we had this stuff.
Yeah,
Okay, yeah. So gravity is also a theory, and most
everything's a theory.
well, most scientists believe gravity is the center of the universe.
No.
Well, yeah. Some think that's a
What'd you
thing.
say?
That's a
What'd
thing.
you say?
I'm not saying.
I didn't hear what
So
you
there's
said.
two.
Some people think gravity is the center of the universe.
There's been two.
That's a theory.
That's a theory.
I'm just
yeah.
saying I believe it because I can't explain it. But my question is, there's gravity on Earth, or there's no gravity on Earth, but once we go into space, all of a sudden it turns off.
There's been two prevailing theories in gravity. One is Isaac Newton's theory, which is the universal law of gravity. Isaac Newton believed that gravity was a force, but he believed it to be a somewhat weak force, because you have an entire planet of this stuff, and you can still jump. You know, it's kind of strange. You need things that are really heavy in order for that force to really prevail. So he believed that essentially once you take mass applies this force to it, that tends to want to bring things
So
closer.
that holds our continents together. That holds the
Yeah.
ocean together. That holds the people together. That holds everything on this planet together.
The more mass you
Until
have,
you go into space.
the more mass you have, the more heavy something gets, and the more of a gravitational attraction it gets. So the Earth is very, very heavy. It also gets a gravitational attraction.
But it's floating in space too.
Yeah. So let me give an example. Imagine. So in year, I believe it was 1054 AD.
Okay.
So China, various Asian countries saw this massive star in the sky that they called the Guest star. It was this massive star, the second to the sun and the moon, outshined everything in the sky. It was this massive thing. Today we know of that as the Crab Nebula. And essentially, a supernova, a star about 10 to 20 times the mass of the sun, exploded, and it created this massive supernova. Now, that star,
Nothing
I got
very
this-
made up theory.
What? A supernova?
Yeah.
Stars exploding?
Yeah.
You think that's a theory?
well, that's the remnant that you see now in the southern hemisphere.
How do you guys know this?
Because you saw an explosion
You
in the
saw
sky.
it? You
well,
saw it?
there's records of an explosion in the sky.
Who?
And now
35
now you
million
have-
years ago, you got records that
It's
that
not
showed it.
35 million years
How
ago.
many
It's
years?
just under 1,000 years ago. So it's in
And they watched it?
1054
Well, he said
AD.
1000
It was discovered
AD,
by about half the
1054.
planet.
That was when Leif
Yeah,
Erikson,
very-
Leif
very-
Erikson discovered about the time the Vikings went into Nova Scotia. He's saying
Yeah.
1,000 years ago. So.
So let's say
First European, by the way, in North America.
within that body
Not
of
Columbus.
mass, we believe. I don't want to try and prove anything, but we believe that there's something called a neutron star. This one was also be a pulsar, which is basically where the magnetic field of the star would become so great that it shoots radiation all around it, and we detect these radio waves coming from the star. But I also have to let this.
I'll tell you what, he's a very mobile guest. He
Well,
doesn't
no,
sit,
I-
does
I
he?
brought some stuff to give kind of
We need like CBS Sports
an example.
in here.
Play by play.
Yeah, well, yeah, it's like football, man. We're not that high tech.
Yeah,
But
so
what are you going to show us here
let's say I had some
before they
neutron
kick us
stars.
out? What are they going to show? What are you going to show us here?
Neutron stars is
Okay, what's your experiment here? But you don't have
I'm about to show
hairspray, do you?
so
No, seriously.
let's say I had something that's stronger, had a stronger gravitational force than Earth.
Anytime anybody puts those on and looks at me, I get scared.
You're right.
Oh, it's nothing scary.
Pucker up.
No, I said, only thing I can think of is prostate.
Yeah.
He's not old enough yet.
Well, he's not. I am.
Yeah.
Let's say I
matter
had
of fact, I need
something
one.
that had a stronger gravitational force than Earth. Say part of this neutron star. A neutron star would essentially, the science behind it would be protons would absorb all of the electrons and it would make pure neutrons, and you would have mass that was.
So what are you going to show us here? What experiment?
I'll show you right now.
Oh, cool. Okay, you're pouring. What is that you're pouring in here?
It's a dye-like substance.
It's like a hair dye.
Close
I
dye.
need some of that too.
Well, let's see. What would the results be if I had something with such a gravitational field? I don't know if you can see this on camera. Is it all right if I move the camera real quick?
Yeah, sure. No, don't. No, hopefully you don't.
Do you want to hold this real quick?
Oh, what am I holding?
Just this dye. I don't
Yeah, sure.
You see that? You wouldn't need.
Oh, wait a minute. Whoa, oh,
I
wow.
was pulling the ink up.
Yeah, it becomes very heavy.
Oh, wow. So, oh shit.
See
You
that?
just
It
made-
would have its own gravitational field.
It looks like a baseball.
Yeah, you got little
What's inside
miniature.
the ink?
It's very difficult to hold this.
What's inside the ink
Uh,
to make it magnetized?
Okay,
to that?
so what are you saying that is right now? That's gravity.
this would be a miniature version that if Isaac Newton's law prevailed, that this would be a miniature.
That's
version.
holding all the continents and everybody on the
That's
planet.
holding everything together. So
And that's
this is-
and
What's-
all
what's-
that. Yeah, all that is ink
what-
and what else?
what's inside the ink to make the magnet?
So I'll give
Alright,
I'll
So
give
let me
away-
explain to the people what he just
right
did.
there. That's
yeah,
disapproved.
I'll give away the illusion. I'll give away the illusion.
That's disapproved. of
Isaac
your-
Newton believed that gravity was a force that was a relatively weak force. So what did I have to do here? I had to pull a little magic trick. Instead of
Pseudoscience.
using gravity, I'm using magnets.
Pseudoscience.
So
You're a
this is
magician.
the world's most powerful magnet. Well, it's the same concept because this thing.
It's the same concept right now. Let me explain to the people what you just did. You basically showed us how gravity works by
it's the same
holding
concept.
everything together.
Yeah, this is holding everything together in the same way that Isaac Newton's model of gravity
And
works.
and all that is ink and what else was it? You
So this is actually a fluid. I did
I'm
this
sorry,
to
I-
create the illusions. So I
what's the-
planned on explaining it. But,
well, what's the thing you had in the it was a metal thing, right?
it's neodymium.
Okay,
Still-
and basically that is the way gravity works and holds the continents together, the water, the people, the animals, and so we don't fall off the face of the earth.
I'm going to set this aside.
float
Yeah,
into
under
space.
Isaac Newton's model, that's how it works. So Einstein came along after Isaac Newton. Isaac Newton created the law of gravity in, I believe, 1665. Einstein came along after Isaac Newton discovered that gravity wasn't as much of a force as much as it's a property of the universe. That things with mass displace something called space-time, and he kind of sounded crazy to a lot of people. But now we understand our models of time and our models of gravity off of special and general relativity, which are Einstein's models.
Okay, now you say that's pseudoscience. What makes you say that's pseudoscience? I mean, he showed basically how
but-
gravity works.
Yeah, you showed me how gravity works, but what's inside that ink to make that be a gravitational
that ink,
pull?
Yeah, that ink is called ferrofluid. You take
What
you
chemicals
take
in there?
small,
Right.
You take
Exactly, that's
small
my
iron
point.
particles like what's in your blood, and you take a very, very strong magnet. That's the world's most powerful magnet. It's called neodymium. You can't.
So that's
create
what that is. That's that the magnet is
that
neodymium.
ball is called neodymium.
And now Isaac
grabs-
Newton's this is Isaac
gra-
Newton's theory here that holds everything together.
Yeah, the Isaac Newton believed.
So it's
that-
got to be really freaking strong to hold all the continents and the water and the people.
Well, it
from falling off the
requires
face of the earth.
requires a really big body of stuff to really get much of a charge. You have to have this big. So essentially, in the early universe, you would have had all of this stuff that's just kind of floating around, and then once it starts to gather up so much in an area, it tends to want to average towards that area until that thing gets really big, and then it falls towards that thing very, very quickly.
So all this proves the Earth is round and gravity's real.
Yeah,
and-
so
and
I was
now-
just doing
now-
that to,
now-
to,
now-
to prove the concept of
Okay,
gravity.
the concept. Okay, now what do flat earthers believe that gravity is a theory, and what's holding everything together? If it's not what he said, what's holding everything together?
What do you mean holding?
Well, I mean-
what's holding us in is
Yes.
the dome and the ice wall, and
So you think-
we're our own contained.
So you
We're
think
our
the
own
ice?
contained
Without-
Hold on. So you think the ice wall and the dome is holding everybody from floating into space?
I don't even know if there is space.
Yes.
All I can
Okay,
see
you
is
wanted
a
the rebuttal?
bubble.
Go right ahead.
So
Because
How do I know there's space? I don't
you
know
can
there's
take
space.
a telescope and see
Yeah, there's-
Andromeda. You can take a telescope, you can see faraway galaxies. I believe there's 3 galaxies you can see with a standard telescope, including Andromeda, which is the one that's nearest us. Actually, scientists currently believe that one day Andromeda is going to consume the Milky Way because it's so close to us.
How do all these constellations stay in place if we're just infinitely traveling through a Milky Way galaxy that is abundant, and we're just spinning around and floating through all this mass, flipping around on a 23.5-degree axis, spinning, rotating.
So you're
around
saying, Rick,
So
hold on.
you're asking multiple questions.
how does all the freaking everything stay in place where we can stay in one
So you're
centralized
saying
point with polarity?
those planets shouldn't be stationary?
You're
saying.
asking multiple questions. So the first question you're asking is, how is it that we're not flung off of the Earth if the Earth is spinning and traveling so fast?
Well, you
No.
just showed us.
I want to know how all the freaking planets.
Okay, I'll
stay-
answer
hold
that
on.
one.
how do all the planets stay intact?
Stationary.
Don't tell me it's a gravitational force, a theory. Don't tell me that it's a theory that you're telling me.
So I started to answer the question, then you start asking another question, and then I
Okay,
have
okay,
to
answer
branch
it,
off.
answer it,
Answer
answer
it.
it.
So
answer it.
how do all of
Yeah.
the stars stay in
Please
place?
explain that to
If
me.
you were to stop the rotation of the Milky Way and take the sun, which is traveling at 514,000 miles an hour
How do
through
you
this
know that?
massive Milky Way.
How did they measure
I'm
that?
giving you a
I wanna
method.
know how they
So
measure
you're
that.
asking me a new question now. Now you're
Okay,
making
let
me
him
branch
finish.
off of
Let
that
him-
question and then answer
let
a
him-
new
go
question,
ahead.
and then you start asking.
But
So if you were to take it and turn it towards the nearest star, which is star Proxima Centauri, it's in the Alpha Centauri star system, and you were to, all the other stars are stops, and you turn the sun towards Proxima Centauri, it would take us over 500 years to reach it. Proxima Centauri is the closest star to us, and it's 4 light years away. That is a mind-numbing distance away. Light being the fastest thing in the universe, I believe also flat earthers believe this, light being the fastest thing in the universe takes 4 years to reach us from Proxima Centauri. So whenever you look at Proxima
So
Centauri,
4 years.
it's a 4-year-old image of the star. So
that's-
all of the stars in the galaxy are traveling in the same direction, and they're all
So they're traveling
mind-numbing.
too.
Yeah, everything in our galaxy is spinning in the
Right,
same
right.
rotation.
I've seen a graph of that
Yeah.
before. That.
So but with how far away everything is, and we're all traveling in the same direction, things will appear to be the same for thousands and thousands and thousands and thousands of years. Because we're all, it's like, imagine you were in a car, and all of the other cars are traveling at the exact same speed as you. They're all going to appear frozen. Now imagine, take that, and put all of the cars thousands of miles from you, and they're all traveling at the exact same speed as you. They all appear frozen. We're all mind-numbingly far apart. So that's my explanation for that. If you're wanting me to explain the method in which we calculate the distance of stars, it has to do with red shifting. We can take the luminosity and we can take the brightness of stars and then calculate the difference to see how much something is red shifted. So essentially, if you look through the color spectrum, on one end of the rainbow you have violet, and on the other end of the rainbow you have red. That's because that violet is the thickest wavelength that humans can see, and on the other end of the rainbow it's the thinnest wavelength that humans can see. The further away things are, the more light has had to stretch out to reach that distance. So things will appear more redshifted the further they are, so we can measure the method. That's the method in which we use to calculate how far things are away.
This is astrophysicists now.
Yeah.
We're getting into astrophysics.
So,
astronomy.
I'm looking
this
at.
is
cosmology.
very
You're basically
Cosmology.
telling me I'm looking at pictures of stars that are 2,000 years old, 3,000 years
Some
old.
of them millions of years old.
No. As we're traveling, I'm saying.
Well, whenever you
So I'm
look,
taking-
whenever
I'm
you
seeing
look at
images-
Proxima Centauri, which is the closest one,
From 4 years
that's
ago.
that's a 4-year-old picture that you're looking at of that
Right
star
now.
because it's taken light 4 years. Light travels around the surface of the Earth 6 times every second, but it's taken 4 years for it to travel to us from Proxima Centauri, and we can measure that wavelength of light to see how far it's traveled.
So what's that prove? What you just explained.
Nothing.
I'm answering his question.
Okay.
As to,
Proves nothing.
Yeah, well, I mean, it doesn't.
Pseudoscience.
Well,
it just
counts-
answers your questions.
Right. Okay.
Yeah,
And
I'm not
and,
trying to.
And now, what do flat earthers believe that there is in space?
Let me ask you a question now, because I've been on
understanding
the
of space
defense.
of flat earthers
Hold your question.
is
What's that?
the water of the oceans is what they consider space.
What's that?
The waters below
The waters below.
oceans
Okay, so-
is what they consider space.
So what are we looking at when we're looking at the sky?
Just the fixed constellation that the Lord built inside the firmament.
I have
That's
a couple
the
questions
firmament.
because I've been on the defense for a little
Okay,
while. I have a
go.
couple questions for Flat Earth.
Sure. Go ahead.
What is Andromeda and what is the southern celestial pole that Octane
I
is
can't
thinking?
answer none of that because I've never got into stars like that. Want to know why? Because I've always thought it was bullshit.
So if all of the stars that we're looking at in the northern hemisphere are rotating counterclockwise around Polaris, and that's the center of the universe, and everything is on one plane, why is it that we're able to see stars on the other celestial pole that are rotating clockwise in the opposite direction
That I
around
can't-
another axis? How are we able
like
to?
I just told you, I've never put my effort into studying the star system like
Cosmology,
that. Yeah,
astronomy.
I get it all, but I don't buy the
I
concept.
encourage you, as a flat earther, try and investigate what is the Southern Celestial Pole. Why does octanes exist? Why are we able to see 360 degrees in all directions? There is no edge.
Because you
of the
are
star
on
chart.
a flat plane surface, so of course you're going to be able to see a 360 degree freaking circle.
I'm not talking about a circle like this. I mean, there's no edge.
He's
to that
talking
circle.
round like
It
this,
goes
right?
Round in all
He's
directions.
talking round. So he's
That I
saying,
can't. That
so-
I can't
so
answer you.
If there was
Because
a dome,
you tried
that
explaining
dome,
this to me because I've never studied
that dome would have an edge to where you wouldn't be able to see past it without being able to see underneath the earth, correct?
I would assume so, yeah.
So why is it that there's no edge? Every direction that we go, we come back on the other end, no matter which direction we
Well,
go.
who's to say that infinity is not the lands that are beyond the Arctic?
But it
Antarctica.
repeats.
I don't know.
Once we get to the southern hemisphere, you can look
Talking
over
Australia,
Antarctica.
South
Yeah.
Africa.
So from any
Zealand.
point on Earth, you can always see half of the star chart, approximately.
Yeah,
It's really
yeah,
close.
that
But
part
once
I
you
get.
get to South Africa or Australia,
You can't see that.
You can see.
You
can see octans, which is the southern celestial
Okay.
pole, and then you
okay
can
for us
see.
stupid people? If you can
Yeah.
see that from, let's say, like South Africa and Australia and New Zealand can see that, but people in North America can't
They can't because they're on
because
this,
it's
anything-
exactly. So that's your proof that the Earth is round.
Yeah, so if you're at the equator, you can see the edge
Yeah,
of both
right.
celestial poles.
So if
You
I'm
can see
sitting
the-
here in Michigan, Ecorse, Michigan, I'm not going to see that star. But if I'm in Australia, if I'm in New Zealand, if I'm in South Africa, if I'm in Fiji, I can see this.
yeah,
What if you flatten this out and took this and put it just on the pole, on the thing? Wouldn't you still see it?
no, there would only be one rotation, so it would never flip to where it would switch and start spinning clockwise. If the entire dome was spinning counterclockwise, you're never going to see a portion 180 degrees away where it's spinning clockwise. Two, if you have to flatten out the Earth, and if the dome, you're calling it dome, if the star chart goes in 360 degrees in all directions, you would never see the portion that's underneath. The reason why you can see the portion that's on the other side of the northern hemisphere is because you're on the other side of the planet. You're looking at a 180 degree angle from your northern axis. This is one axis, this is the other axis. So whenever you look at octanes,
I cannot grasp that. I don't understand.
Here,
I'm not grasping what you're trying to tell me.
Well, he's
Just
saying
in
that
case,
if
I
you
built
could,
a little-
if we're in North America, you're in, let's say, Ontario, you won't be able to see that star. And he's saying because you can't see that star because the Earth is round. But the further south you go, you can see that star.
so here's what I'm saying.
That part,
Here's
I
Polaris.
understand though. I get
Okay,
it now.
and
Here's
let's-
Polaris. So on round Earth model, Earth is spinning in this direction. On flat Earth model,
Well, he's got
the
it all
box is
today.
what's
Where the hell
spinning.
are you pulling this shit
The
out
box
of?
is what's spinning
You're
on this
studying.
direction.
I know, it's
Polaris,
great.
all the stars rotate counterclockwise around Polaris.
Yep.
You take that same counterclockwise motion, you look down, it spins clockwise. On a flat Earth that can see Polaris spinning counterclockwise.
The people can see this over here.
On a flat, here, let me bring it over there.
Bring
They
it over
can
there.
see it.
Okay, so
On a flat Earth, where this is the same portion of Earth on both models, on a flat Earth where we see Polaris and all the stars spinning counterclockwise around Polaris, you should not be able to see 180 degrees in all directions on the other side of the planet to where the stars, the same rotation, east to west direction, would spin clockwise. The only reason you can do that is because it's on the opposite side of the planet. If the star chart goes around the planet in 360 degrees in all directions, then flat Earth would never be able to see this direction. They would never be able to see that axis.
So that's conclusive. You think that, hey, that's your proof that the Earth is round.
So flat Earth has actually a very
I can't argue that one. That one I will not argue because one, I've never studied the star charts like that.
Okay, all right.
I've been into cosmology for a while, so it's
That's fair.
I can't. I've never. And
So
to be
I-
honest, I've never heard that debate or
octanes.
anything like that.
let me
I've never heard them bring it up like that.
Here, to give us a simplistic model, I'll just show this real quick because I
Oh, okay, you're gonna turn the lights off. All right, keep your hands away from me, buddy.
So the special thing about
Hey,
this,
it's dark.
it actually has Polaris on here.
Cool.
One rotation that shows. Let me make sure this is counter. Yeah, one rotation that
That
shows
glows in the dark,
Polaris
there's no clue.
It's his nightlight.
spinning counterclockwise.
Which is a flat one?
On the other side
I walk
shows
in the dark.
octans spinning clockwise.
Okay,
Because it's 180 degrees away from Polaris in all directions.
gotcha.
It's on the other axis.
That's cool. Okay, all right. Wow, that's
Yeah,
awesome.
it has the whole star chart.
Yeah, that's crazy.
And this is a complete star chart. Some flat Earth star charts will only show the northern hemisphere. Some of them end right here.
So
they just break.
how does it work for navigational through the waters?
What do you mean?
How did they navigate through the waters with it?
I mean, it's the same model. You just flat earthers believe that.
How do they know to come when they're traveling? You know, and they know to come to this.
So on the
system.
round Earth model, a straight line is just slightly is curves on a flat Earth model. So I mean, whenever you're traveling over the ocean, mostly you're using magnetic north. Flat Earth just believes that magnetic south is a ring that points away from magnetic north. Round Earth model believes that magnetic south is the southern pole.
I'm saying they use the stars to map themselves to sail.
Yes, and if they had a star chart and used the stars in a flat map to where there was an edge, then they didn't know about the entire map. So if you go back
Then
to
how did they depict? How did they
Norse, if you go back to Norse religions, oftentimes the different religions would have star charts of only their half of the planet, and they'd end the star charts before
there's
it gets
maps
to.
that date back to the 12 and 1300s that depict
They have a
Antarctica.
completely round. So the Greeks were the ones as I searched.
1400s, 1500s. Yes, they sure do.
Oh.
The Gleason map of the 1800s.
I'm not saying that
the 1800s have it.
So I'm not saying that there's not been societies throughout history that haven't had a flat Earth model. I have no disagreements with that.
Oh, I understand that.
Yeah. But if you're basing your belief system off of what other people historically have believed, then you're by definition believing in a narrative. I'm observing, trying to
I'm
present to
believing in
you.
the narrative.
Well, you both believe in
we
it.
all believe
You
in
both believe
narratives.
in a
We all
narrative.
have an
Yeah,
agenda.
right.
We all have
Sure.
things that we want to accomplish in life. But if you're basing your belief system entirely off of discoveries that other people have done, then you're doing what flat earthers say round earthers have been doing for the past couple centuries.
I'm not saying that.
But you keep asking me, why is it that this group of people has found this conclusion? Why has this group of people found this conclusion?
I'm just
Different
asking
people have
questions.
found, yeah.
Now, I want to ask you a question. When did the flat Earth theory become so popular? I mean, what? All of a sudden, it just took off.
I probably like 12 years ago.
Was it 12 years
About
ago?
12, 13 years ago. They started a big thing talking about it.
More closer, and so the people can
I think with the
12, 13
popularity,
years ago.
come back from the other side of the ice wall. Run.
I've noticed a lot
So
of.
when, because I've noticed lately that it's become really popular, and it's really making a move. Where like 30 years ago, you'd have talked about it. More people like, yeah, right. That's
Exactly.
stupid, right?
Exactly.
But I mean, look where we're at today. I mean, we got the internet, which was created by DARPA. There's a reason why. I mean, there's a lot of misinformation out there, and there's a reason why there is misinformation. And you guys both bring up great points. Like I said, I really don't have a dog in this fight. My only proof, but you come up with great points, and you debated great too. My only belief is, my proof is, like I said, flying on a plane, seeing the Earth's curvature. But there's bigger fish to fry for me. As far as politics goes and geopolitical, I know that's not your forte, but there is a lot of disinformation
A lot of disinformation.
on both sides.
Big time.
And to come up with a conclusion that, the Earth is round, I mean, people are going to believe what they want to at the end of the day. But, there are, and you believe a lot what I believe, there's a group of people out there that definitely love this debate because it kind of distracts us from the real craziness going on.
And a point I want to make too is seeing the paperwork from like NASA and military and things like that that states that it's a flat, non-rotating surface.
So NASA knows.
Yeah, NASA and navigational, planes.
Well, I would
and,
say-
pilots and things like that. And it says it
Oh,
on the
and hold on,
document.
he stretched on
So
something.
I
Maybe,
would
maybe
say-
hold on,
and the star system thing, that is cool.
Wait, it's my show. Hold on.
I like the star system.
Okay,
That was great.
let me,
Great presentation on that, Brandon.
No,
Appreciate
it was
That-
great. No,
that-
he
that
did great.
was-
Both
that
of you
was
guys, and you debated great too. But I want to ask him a question, which goes back to the flat Earth people, and we talked about it. Why when you go into like into the Arctic and even into the North Pole, that you're only allowed to fly like 12,000 feet? What's the whole thing behind that? Like you can't go higher than 12,000 feet. I guess the flat Earth people believe because of the dome.
Yeah, that's what they say. That's what they say.
Have you heard that?
I think it's like
what's
13,000.
what's
I
your-
think there's not a lot of traffic going over.
But why are they
Antarctica.
only limited to fly 12,000 feet in the air? It's like,
Well,
why?
I've not heard
So
of it.
that's a debate that
Yeah, I'd have to look
flat,
at that.
okay, that's a debate that flat earthers say. And it brings up a good point. It's like, okay,
Grab
what
us
are they
all
saying?
over my face.
What's that?
I just touched my face. And
Oh, it's okay. You can turn the lights off. We won't see it.
Glow in the dark.
No, I just wanted to thank you both for coming on today, and we're reached the end of our show. Great debating, great presentation.
Great celestial presentation.
And you
Brandon.
too,
That was
Rick,
awesome,
you
dude.
ran some great points. At the end of the day, I don't think we exist. This
We
is
live in
all
the
a
Matrix.
psyop. This is what you call a simulation. It's God's simulation. I don't know.
The Matrix.
Yeah,
brother.
it is the Matrix. That's what I'm convinced we live in the Matrix.
I agree.
I don't know if it's round or flat, but I do know I
It's
love
a
my
flat,
women round.
non-rotating surface. All right.
But
Hey,
before.
you know what I'd say? If you believe that because NASA's telling that, you need to stop following NASA's agenda.
There you go. There you go. I agree with that. We don't believe in NASA. It was created by a bunch of Nazis, anyways. Von Braun.
Werner. Operation
Yeah,
Paperclip.
we know that's our government bringing Nazis over to help build the rise of the Fourth Reich. So yeah, that's crazy. So we're nearing the end of the show. I wanted to. I had an asshole of the week 2 weeks ago, and I want to bring him up. My asshole of the week was Ben Shapiro.
Yeah,
this-
Ben Shapiro?
yeah,
No, no.
he's
Deserving.
this little twerp who doesn't. He pretends like he's can speak Hebrew, but he really can't. He speaks Hebrew like you speak Greek. And this guy was so funny. This guy's a
shit,
mouthpiece for Netanyahu in Israel. This guy's my asshole of the week. I'll tell you
He's a
why.
Zionist, dude.
Oh, big time. Because he's trying to tell the American people that you shouldn't be able to retire. Can you believe this, little twerp? You shouldn't retire. You shouldn't be in Florida sipping on a Mai Tai, drinking alcohol. No, you should work till you drop dead. This same guy that wants to cut government options, cut government spending, cut Medicare, cut Medicaid, but he's okay with giving $6 billion to Israel. I suggest you board on a plane, go to Israel, pay their taxes, and join the IDF. And don't tell me what we should do with our money. Ben Shapiro, you are asshole of the week, and I'm pretty sure he thinks the earth is round. Because that's the only way you can get paid. Nevertheless, I want to thank everybody for tuning in, the two people that did tune in. And thank you, Brandon, again. You guys did great.
Yeah,
Oh,
thank
you
you.
got
No, you got
and
Andy.
Rick
Yeah.
from the other side of the ice wall.
That's me.
Join us next week. Hopefully, Dean will be here if his wife lets him leave the house. He'll be back from the Betty Ford Clinic, and we'll have our normal show as usual. Thank you, guys, and see you next week.
Awesome.
Have a good one.
Awesome.